Hey everyone, it's Tony and welcome to Hidden Light Photography. Today we're going to be going through some basic equipment that you need for astrophotography. And astrophotography in a nutshell is photographing celestial objects. So some things that you're going to need, obviously, is going to be your telescope. There's some pieces to the entire setup that you're going to need to be familiar with. And this right here is going to be the OTA or optical tube assembly. On a Newtonian reflector like this one right here behind me. This actually contains mirrors which will gather the light from the object that you're imaging and reflect it into your camera. Now, I'm going to go through my setup, kind of give a brief explanation as to what everything does. This blue guy right here is going to be a Pegasus Astro Falcon rotator, and what this does is as I'm framing my image in Nina, I can orientate how I want that image to be in the frame, and this will actually allow that to happen, and it does it automatically. Nina will take a picture and it'll plate solve it, which means it takes the stars that are in the field, compares it to a star chart, and then it knows the orientation and location. It'll actually send a signal to the rotator to rotate the camera, and it'll make the image, the final image, exactly how I have it framed. And the next piece is going to be your actual camera. This particular one is an ASI 2600 MC camera. It's a one-shot color camera. I also run an ASI 533 MC camera, which is also a one-shot color camera. The difference between the two and why I have both of them is each one has a different field. This 2600 behind me has a rectangle sensor, and I can get a little bit more in it than the 533, which is a square sensor. So depending on what I'm imaging for the night, will determine which camera I use, and we'll get into field of view and all of that later. The next thing that you're going to need is a good tracking mount. This one is a Skywatcher EQ6R Pro. It's a belt-driven mount, and it's whisper quiet. It tracks amazing. I highly recommend it. My first setup was a Celestron AVX mount, another great mount. In fact, the reason I got this is because I wanted to upgrade my scope. My original one was a Celestron Omni XLT 150 reflector, and that was a 6-inch Newtonian. This scope is quite a bit heavier. Unfortunately, the AVX, the payload capacity on that I think is 25 pounds. This scope, set up as is behind me, weighs closer to 30 pounds. So I needed a mount that can handle that kind of payload. Heard a lot of good reviews on the EQ6, so I went with it. Had it for a couple of months, very good success. Had some connection issues in the beginning. Don't let that deter you. If you're considering this mount, I will show you how to overcome that. But the reason you need a tracking mount for this is as the Earth rotates, the stars go across the night sky. We all see that. We can see it in the moon, and as we're watching constellations go across the night sky. We need to be able to track that because the whole object or objective in astrophotography is getting the best possible signal to noise. And how you do that is you stack many pictures on top of each other. And depending on the target, the brightness of the sky, or how dark the sky is all going to determine your exposure times. And when you're getting into longer exposures, you're gonna need a mount that can track. Otherwise, you'll end up with elongated stars, double images, and you're gonna be throwing out a lot of subframes and wasting a lot of time. That brings me to the next piece, which is gonna be guidance. I highly recommend a guider. This particular one is an Orion Starshoot Mini Auto Guider. The guide scope here is an Orion 50mm aperture by 162mm focal length, and it can effectively guide 1500mm of focal length on your primary OTA. And the kit also includes the Orion Mini Starshoot camera. This system has been very reliable for me. And what this does is it'll actually lock onto a star in its field, and it'll keep that star centered. And how it does that is it is taking pictures. My setup, and it depends on the sky that you're in, some other factors, but I will generally run 1 second exposures, and as that star is moving, depending on seeing and your tracking errors and now just to pause for a second, tracking errors and polar alignment errors is what this guiding is for. Now, as it's taking those photos and that star is moving around, it'll send commands to the mount to adjust your right ascension and declination to keep it centered. And that is the whole purpose of that. That is how it'll keep your image centered and allow you to get long exposure times without elongating your stars, doubling stars, as long as you have everything set up correctly, which we'll go over that in another video. The other pieces that I run is I will run a flat panel. This is for calibration frames, and we'll get into calibration frames later, but this is important. This is how you calibrate out dust particles on your mirrors. This is how you help with, excess light pollution, gradients, all that stuff. And when we get into our processing video, I'll show you how to use the frames that you take with this to calibrate everything. The other things that I run are filters. I use an Optolong L Ultimate filter for nebula, and I use an Optolong L Pro filter for galaxies. And what these do is they are set up to allow a certain frequency of light to pass. So if you're in a heavily light polluted area, this is where to go. Now, these filters will also focus on your different gases, hydrogen alpha, oxygen 3, so on and so forth. And what I find with that is I actually need less integration time, and I get better quality images, and the data is a lot easier to work with when you're processing. And we'll get into processing in another video, but for now I want to focus on equipment. Now, when you're choosing your equipment, the next video that I make is going to be how to choose an OTA that'll fit your needs, how to choose a camera that'll match the OTA. That's another very important aspect, because it is easy to undersample or oversample your data, and that just makes it harder to work with when you're processing. So it sounds complicated. Stay with me. It's really not that bad, and I'm going to teach you everything that I know, all the resources that I've gone through. I've researched until my brain hurt, and that is the purpose of this, is to pass on everything that I know, all of the questions that I had, the issues that I ran into, how I corrected them, because this is a beautiful hobby, very fulfilling, and I want everyone that is interested in this to enjoy it and be able to have a source to look back on in order to correct or overcome the hurdles that they run into. Because I don't want to mislead anyone. You're gonna run into issues. That's part of it. And knowing how this stuff works and how to overcome it is what makes this hobby enjoyable, and be able to create beautiful images that you can share with your friends and family. So for now, I'm going to leave it at that. Stay tuned for the next video on how to choose an OTA and how to choose a camera to match it. One last thing I want to leave you on is you don't need the most expensive stuff. I was looking at OTAs that were $3,000, $5,000, and I got this for $830, a fraction of the cost. And I'm going to give you a secret. The optical train in this is the same as those OTAs. I am very fond of Cinta optics, and a lot of these, I can't remember the particular brand of OTA, but it was $5,000, uses Cinta optics. And another fun fact, my Celestron Omni XLT, which I think was a $400 tube, not even meant for imaging. If you have seen my introductory video, every single image in that video, except for the last image, was taken with that Celestron. Now, why did I go with this? I wanted more aperture. And the other thing too is in this you have baffle rings, which will help help with stray light, and the focuser is a little bit better, but stability is everything on these. One last thing I want to go over is focusing. Focusing is absolutely critical to this, because without good focus, you're not going to have a good final image. So one way that I do this is actually with an automatic focuser. This right here is the ZWO electronic automatic focuser. Great piece of equipment, very, very useful, very easy to use. And what it does is it'll actually automate my focusing. Now, initially I have to get it close, and we'll go over how to do that when I show you how to use this piece of equipment. But what it'll allow me to do is automate the focusing process throughout a session. So for example, I will have it do an autofocus run at the start of a session, and as the half flux radius, or in the most basic terms, how big the stars are, increases 10%. You can also have it autofocus after a set amount of time. Now, why is this important? Why is it so useful to have an automatic focuser? As the night goes on and temperatures change, so does your focus. So if you're not planning on being out there monitoring your half flux radius and stopping the session and doing a focus by hand throughout the night, this is a great piece of equipment to have because it automates it. Anyway, that's all I have for this, and if you have any questions, please feel free to send them to the email address listed or comment on the video. Just give me 24 to 48 hours to respond. If you like this, you find it useful, you want me to keep going with it, please like and subscribe, and stay tuned for the next video where we'll talk about how to choose an OTA and how to choose a camera to match that. Until then, clear skies.